One.
Hello, excuse me. Hello and welcome. We appreciate you joining us today. And I do hope you are having a productive and, depending on where you're located, a safe day. I'm your host, Charles Collegy, the Security Analyst for Accelerated Strategies Group. Today's Security Boulevard webinar is brought to you by Cyral. And I have with me Rob Richardson, the developer advocate at Cyral. Hey, it's nice to see you again, Rob.
And great to see you. I'm glad to be here.
And we're happy to have you. And all of you are going to have a very entertaining time. And Rob will be speaking on how to discover data exfiltration in minutes, not months. Rob, you've kind of introduced yourself, but say hello to the audience again.
Hello, everyone. I'm so glad to be here. I'm a developer advocate for Cyral, and it's so much fun getting to show you how to prevent data exfiltration. Thanks for joining us.
And Rob is really eager to discuss why it's critical to understand data usage patterns, to find the access rights abuse, and ultimately potential data leaks. And he's going to demonstrate Cyral's tools for these functions. However, the meat of today's webinar must be delayed just a few moments as I handle the housekeeping items. Now, please note that this webinar is being recorded. Later, it will be available on demand, and you will receive an email with the link. But at any time, you can go to securityboulevard.com and gain access to this and all of the archived on-demand webinars we have available. So take some time later today and peruse our webinar library. Now, just a few comments on the Big Marker platform. First, on the right-hand side of the screen, you'll see the chat button. This feature allows everyone online to interact during today's event. Say hello. Let us know where you're coming from, where you're located. Feel free to provide any comments and provide feedback. I'm sure Rob will want to hear exactly what you're interested in to help him as he moves forward in this. Now, for questions, we do ask that you not use the chat. As chat scrolls down, some questions might be missed. So it's best to use the Q&A window, which is accessed right next to the chat tab. And we'll try to answer as many of your submitted questions as possible before the end of today's session. Now, if we're not able to, I'm sure that Cyral will follow up. Now, you'll also see a handouts button all the way to the right. And here you can download some white papers that are available and a link to today's deck. Now, Rob is doing a demonstration, so when that occurs, it might be best to go with a full screen, which you can do by clicking on those two opposing arrows on the right-hand corner of the screen. Now, and many of you have attended these before, you know that the most important housekeeping item is that at the end of today's webinar, we will be awarding 4 $25 Amazon gift cards. So please stay with us till the end to see if you're selected. So now it's time to jump into today's session. Rob, the ball is now in your court.
Awesome. This is such a fun talk, and I'm so glad you're joining us. We're going to talk about how to detect data exfiltration. Now, here's the part where I tell you I am definitely going to post the slides on my site tonight. If you've ever been in a talk and heard the speaker say that, has it ever worked out for you? Hasn't for me. This is why you can go to robrich.org right now. Click on presentations right here at the top. And here's the content, and the slides are available online right now. You'll notice that I'm browsing the slides from my site as well. While we're here on robrich.org, let's talk about some of the things that I've done recently. We'll click on About Me. I'm a Cyral developer advocate, a Microsoft MVP, a friend of Redgate. And let me tell you a little bit about AZ Give Camp. AZ Give Camp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver that completed software back to the charity. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp in your neighborhood, hit me up on email or Twitter, and let's get a Give Camp near you. Some of the other things that I'm doing, I do a lot of training with security and containers. And one of my claims to fame, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into how to discover data exfiltration in minutes, not months. We talked about this guy. Who accessed your data? Now, we've had a lot of fun so far, but this question may make you a little bit uneasy. It was really easy to ask, but it's kind of hard to answer. I feel like I'm under the microscope. Or even worse, that I'm in the chair getting interrogated. Who accessed your data? Well, when we start to ask this question, it might be because we're in the middle of an audit and we need to justify our behavior over the last few months, prove that we'll be similarly well behaved in the next 2 months. Or maybe we're starting from a data leak cleanup where we need to, solve the problems of how our data escaped. Or maybe we're looking at a data integrity problem where our data is corrupted and we're trying to find the root cause. So we ask that question, who accessed our data? And well, it's kind of difficult to answer. So first off, let's head off to the logs. Now the logs are interesting, but well, the logs are probably missing. Yeah, there are no database logs. This is not an uncommon configuration for us to just disable the database logs. So, how do we answer the question about who accessed our data if we don't have logs for the database? Or more succinctly, why did we turn off the database logs? Let's dig into that one. Well, the most latency part of our application, the slowest part of our application, is probably accessing the data. And the slowest part about getting at the data is reading the data off of disk. So if we want to read the data off disk and also write that access to disk, we've increased the latency of our data access tier, which increases the latency in our application. So to speed up the application, we may choose not to log the database data. Yeah, we increase the speed of our application by disabling our database logs. In time, those database logs may start taking up a significant amount of our hard drive space. And well, we want to keep the database running smoothly. So we'll either prune these database logs really tightly, or we'll just leave off the logs completely. We're trying to save disk space because the goal of our data access is to be able to facilitate that data that our application needs. So anything that's getting in the way is, extraneous, and we start to turn these things off. Well, after all, our application is logging all of this request detail anyway. So when they ask who accessed your data, we're going to flip over to the app logs, and the app logs will kind of give us a better read here. So here in the app logs, now we have our fancy dashboards, and we're able to pull up which users accessed our application, and we can talk about dates and times and the activities that they did. And we get a really nice and elegant answer to that who accessed our data question. Well, kind of. Did all the data access go through our application? Now, that is a convenient lie that we told ourselves, and maybe it got us past audit, but in a data exfiltration attack or in a data integrity issue, that may not answer the question at all. Who has access to our data? Is the app the only thing that accesses our data? I would propose no. Let's enumerate all of the places where other things might access our data. Maybe an SRE jumps in to fix something quick. While the customer is on the phone, they're going to go into their account and adjust data to make it look correct. Or maybe a DBA notices a slowdown in the application and jumps into the database to tune an index or to rebuild a query to make that more efficient. Are they going through the application? They're probably not. They're probably accessing the database directly. Deployment tools. As we deploy the next version of the application, we need to migrate our database schema to match. And that database migration tool definitely isn't using the application to make these changes. We might use bulk data extract tools for onboarding new customers or helping customers that are leaving. We need to go grab all of their data. And, well, we're probably not accessing the application to make this happen. What are other instances where you use your database, but not through the application? Set them here in chat. So we can see that pretending that the application logs help us answer the question of who has access to the database, that may not get us where we need to go. Yeah, it's a convenient lie and it'll hold up for a while, but it really doesn't enumerate all of the places that we can use our database.
Hey, Rob,
so let's return to the database logs.
Yeah, Rob, I got a quick question come up.
Definitely.
Is there a way to know that your logs are turned off, or is there some kind of quick way to know if we are logging things?
Yeah, definitely. Let's dig in straight there. Let's take a look more at the database logs and see how we turned them off and how we can turn them back on. Great question.
It worked out right. Worked out timely.
Yeah. So I've got this application here, and my application is able to use the database, and I can log in. So let's log into this application. I will log in with Audrey, the person in accounting. And I will start to use my application. Let's say we'll come in here to project tasks, and I want to create a new project. Logging into logging database queries. And I will save that. Obviously, we've got some data saved. It's going to the database. Here in my Docker Compose file, we see that we've got our database running. And so we should see content here in this Postgres folder that is the logs in the logs folder. But, well, the logs folder is empty. So that's the magic sauce that we can see. We went to go look for the logs and there aren't any. Well, it turns out in Postgres, by default, unless we specify the log statement, then logs are disabled. The default is none. So here in our Docker Compose file, if we just say Postgres or if we leave the command off, then we've disabled logging, much like saying log statement is none. Now, your database log vendor may differ, but you've probably also tuned these logs to be smaller, or your DBA has, to avoid those things of additional latency on the disk or to avoid filling up the disk. So I want more logs. Let's turn off the no logging and turn on the yes, I do want to log. And now let's come restart our database. So I'm going to take down these containers. And let's take down those. We took down both the database and the admin tool. Now let's spin them back up with that new configuration where we're logging. Now I'm going to log into my application again. I will refresh this content. So I'll select that. Oh, my request failed. I bet my database isn't up yet. It's on the way up. There we go. So now we've got some database access. We can log in this way as well. So let's log in as Postgres. And we are logged into the database. And let's take a look at this task table. We can run a SQL command, select star from task. Let's execute that. And we can see the data out of our database back in here. We can now see that we have that log folder. Perfect. We turned on the database logs. Very nice. Let's pop open this log file and take a look at the content that we see here in this log file. Okay, so we deallocated some things. We have some select statements that populate the UI in adminer. We've got some other views. We did this query, select star from task. There's that query right there. So we've got a lot of interesting content here in the log, but our magic question is, who accessed our data? And in this case, these logs don't help us answer that question at all. Now, why is that? Well, in both the application and in the admin tool, we used a single service account. Now, probably the DBA went and popped open the configuration file for the application, went and grabbed the username and password out of this configuration file and used that to log into the database because, well, that's where the database credentials are stored. We all used the same service account. Now, maybe we got Audrey, the person in accounting, to use the application, so we have the application's logs. Maybe Cyral from the SRE team, we gave them an SRE account, but still we have groups of accounts. We don't have users. And more likely than not, all we have is, well, the service account did it. So that was a great question. How do we know if our logs are disabled? Go look in the logs folder and then go look for the documentation that helps you turn on the logs. You may choose to replicate these logs to another server so that you can use them in a more durable way as well. But ultimately, yeah, we we got the database logs, and all the database logs said was, well, we've got a bunch of service account connections, and that's all. So we've got some problems with our database logs. We don't have any SSO information. We probably all share the same service account. So even if we did have any identity information in our logs, it mostly only says the service account did everything. We're still no closer to answering the question, who accessed our data? And well, we probably turned off our logs for performance reasons, either for performance of our application or to make our disk perform better. So yeah, database logs really aren't getting us where we need to go. So yeah, database logs don't include user identity. That's too bad. What can we do about that? Well, let's take a look at logging in with SSO for applications. For applications, this is a really well-solved problem, and we can do this really elegantly. How do we do that? Well, the user launches the web app. We'll click the login button. It'll forward us off to our identity provider. So maybe we're logging in with Okta or with Google. Maybe we click the login with Facebook or GitHub button. We're back on that site and we're logging in with Google or with Facebook. Once we log in, we get redirected back to the application, and now we are able to get our work done. That's perfect. As we look at that mechanism inside of SSO, we have a really elegant mechanism where the application, the identity provider, and the user work together to create this really elegant solution. So let's take a look at that application. I've got this application where I've logged in with Okta. And here in Okta, I can take a look at my configuration. I have one web app for logging into my application, and I have another web app for SREs. So I log into that application and log into my application. I'll put in my credentials. In this case, we're logging in as Audrey from accounting. And the hardest part of this demo, remembering my password. And now I'm logged in. Now we went off to Okta, we logged in through Okta, and we came back with a list of details about this user. Now my application didn't need to store credentials, but I know what SSO groups I'm part of. I also have other interesting information, like is my email address verified? What is the username and email address associated with this account? First and last name. All of these details are great, together with my unique ID from that SSO provider. These are all the details that I can use then to get access to my essential resources and be able to accomplish the task that I need. In this case, with that SSO empowered application, the identity provider was able to keep the credentials safe, and as a user, I can now get access to the resources. So we have that identity provider, we have the application, sometimes it's called a service provider, and we have the user. These three parts work together to make this happen. The identity provider keeps the credentials stored securely. It's the only place that validates that username and password, the only place that stores it. So we can use a single account across many applications. When the time comes that we authenticate to that SSO provider, the identity provider, then that identity provider provides the application a rich user context, including a verified identity and group memberships. That's great. The application doesn't need to do any authentication details, but it can use those SSO groups and other details to make authorization details within our application. We can, in the application, log that rich context of the user and their behaviors together. And from a user's perspective, if I was already logged into my identity provider, maybe I just clicked the login with Google or login with GitHub button. I forwarded off to GitHub and back, and I didn't need to do anything. It was a really elegant experience to log into that application. So SSO works really well with applications. Why can't we do SSO with data? It is kind of a solved problem with applications, and it's really elegant. Could we do this with our database? That would give us the answer to that magic question: who accessed our data? Well, we can, but we can't. SSO works really well for getting access to cloud resources or to SaaS applications, but we don't have SAML or OIDC with cloud databases or on-prem databases. And that kind of makes sense, kind of. The first step in our journey with SSO is to redirect off to that login page. Now, how do I answer the question, select star from task with a, can you redirect off to this login page? That's just not a thing that data protocols understand how to do. So what do we want? What is the ideal solution for this? Now, we want to be able to answer the question, who accessed our data? We want to be able to use SSO in really elegant ways. So let's imagine a world where we had our ideal logs. Well, in my ideal log, I would have the SSO username, the SSO group, the SQL query, the result count, the client connection details, their IP address perhaps, the date and time of their request. And well, we have all of this with SSO details, with applications. With an application, we have the authenticated user and their groups, their claims. We have the request query, their URL. And we have the response details, the number of bytes served and the status code. We also have the client connection details and the date and time. We have this with our applications. Let's bring this into our data access as well. We want that SSO details together with the request and response details so that we can very concretely answer who accessed our data. So let's add Cyral. Cyral is a federated access control system that allows us consolidated policies and monitoring, real-time attack response. It allows us to bring SSO into our data. On the left, we have kind of a standard setup. And on the right, we have our mechanism with adding Cyral. On the left, we're logging into our identity provider, in this case, Okta. And once we log in, we get this JWT, this JOT. Now, this JOT token we can use to authenticate into our microservices and pass that identity context around between each of those services. If any service doesn't have the correct identity, we can go back to Okta to log in differently or to be able to access different groups. But once we get outside microservices to our data, then we lose that identity context because our microservices probably use that shared service account to access the data. We've lost that identity context. By comparison, in a situation with Cyral, we're using that same front end. We're logging into our identity provider, and we're using that JOT in all of our microservices. We're now also passing that JOT into our data access tier. Now with that JOT, we can log the user identity together with the request and response details, and then ultimately Cyral can proxy that request off to the data store using a service count. So now we've got user identity in our logs associated with data access. Now this is great for access inside of the application, and we also noted that, well, we can access the data from terminals as well. So SRE or DBA or other tools probably use a terminal to get access to our database. Right now, they're using that same shared credentials to access the data store, so we've lost that identity context. Let's add Cyral, and from the terminal, we can go get a JOT representing that user's identity and use the JOT to authenticate into the Cyral sidecar. From there, we proxy that data off to the database, and we're able to log not only the request and response and connection details, but also the user's identity. This is great. With Cyral, we can use various federated access controls, Okta, Azure Active Directory, G Suite, and more. We can connect to various data stores. Today, we're using Postgres, but we could also use MariaDB, Mongo, SQL Server, and others. We can talk about consolidated policies. This talk is focused less on policies, but if you'd like to learn more about consolidating your access policies and blocking unwanted requests, hit us up at info@cyral.com, and let's show you more about the policies. And then ultimately, we can pass these data, this log, to Elk or Splunk, Datadog, Sumo Logic, and others. Today, we're going to use Splunk. So let's dig in and take a look at this. Well, we have this application, and we know that this application is logged in through Okta. Here's our Okta setup, and we've been using this Cyral web app to be able to authenticate our application. Now, we also want to use this Cyral maintenance app for all of our non-application activity. Now, in this Cyral web app, we very specifically identified that the users that can access this need to be in the, that is right. Sign on assignments. Yeah, there we go. All the people that use this Cyral web app need to be part of the accounting group. By comparison, inside this other maintenance app, then users need to be part of a different group. So let's go into assignments and we can take a look at groups, and they need to be part of the SRE group. Now we could definitely assign more groups to these applications, but that'll help us give additional identity and context to this. So we have these two applications, the web app that we use for authentication into our web app, and the Cyral maintenance app that will allow us access into our data store from non-application scenarios. Inside the Cyral dashboard, we can hook up various data repositories. You'll see in this case, I've got a connection to MariaDB, Mongo, and also Postgres. Let's dive into the Postgres configuration. Now, I do need to authenticate into the database using a database account, and I don't want to duplicate all of my user identities in the database. So I'm just using a single account to authenticate to the final lap of that connection. And so here's that native identity. Now I can map my identities from my Okta setup into that account. So you'll see that SRE accounts go into that Postgres account. Now here in the advanced settings, I can allow you to log in natively to the application. I have this turned on for now so that my demos will work, but we can also disable this so that you can only log into the database using these SSO credentials. So now I've got some integrations. Now we did talk about how I integrated Okta previously. So I came in here and I clicked on configure and I filled in the details associated with that application in Okta. I've also chose to integrate in Splunk. So as I go configure my database, I can get access to Splunk as well. So let's do that. Here in our application, we need to integrate with our SSO provider. We've got Okta set up and that works great. We also need to integrate non-app access with SSO as well. Let's take that for a spin. So here in my application, I have my environment variable currently going to the database directly. That's my Docker Compose port right here, 5442. I'm going to flip this over to my Cyral sidecar on 5432. I'm also going to choose to log the identity of the user coming in. So right now, I don't have anything set at the top of each of these requests. And I'm going to choose to add this Cyral context query. Now, this Cyral context allows me to map the details of my JOT token into the details that Cyral is looking for that identity verification. Okay, now that I've got that set, let's restart the backend application. And now the backend application is not going to the database directly, but rather going to the Cyral sidecar. That's perfect. Now the Cyral sidecar will proxy that data off to the database. And so you can see if I come in here and say, I would like to log my database queries, then we still have access to our application. Oh, I may need to log out and log back in. Let's log out. Let's log back into our application. Audrey is from accounting. And so let's log in as Audrey's account. And now we can get access to our data. Let's log database queries. Perfect. Now we also want to be able to access our database from non-application accounts. So rather than connecting to my database, I'm going to connect to my Cyral sidecar. That just happens to be the name of the container that I've started to do this. Now, rather than logging in as my native credentials, I'm going to log in instead as IDP, specifying that I'm logging in from my Okta identity provider, and I'll log in as Skylar. I'm going to log into the Cyral database again. Now, what is my password? Well, it's not the password that I use to log into Okta, but rather I can come here into the Cyral console and I can grab my access token. Now, this access token is a short-lived token that allows me to authenticate to data stores, and Cyral will use this to be able to pull the identity information out of that detail. So I'll use that as my password, and that'll work for the next few minutes. Ooh, I need to refresh this screen to be able to get a new token. So let's pick a new page and grab my access token. Let's copy that. And now I will log into the database. Ooh, token is expired. Let me log out of the dashboard here and log back in. I am not assigned this Cyral app. Okay, so that's going to be a fail. Am I logged in as the wrong user here? Let me sign out as Skylar and sign back in. Okay, so now that I'm logged in as Skylar, let me come back in. Oh, that's why I'm logged in. I'm logged in as Audrey. Let me sign out as Audrey and sign back in as Skylar. I did log in as Audrey last, so that will definitely get me here. Okay, so now that I'm logged in here, now I can go back to my Cyral portal, log in correctly as Skylar. There we go. And let's go grab the access token. There we go. So we've got our access token copied. And now I will log into my database as Skylar. Oh, fail. So let me log in as myself. That may get us to this answer a little bit faster.
Rob, while you're doing that, how long does that token last since you had that expiration issue?
It lasts about 5 minutes. And so that's why I find it interesting that even logging out and logging back in, I'm still getting that authentication failure. And of course, in all of the times that I've practiced this, it works flawlessly, but on stage, of course, it's going to fail.
Yep. It's the rules. That's the rules.
Yes. Nope. I'm still getting a fail. Token is expired by 46 minutes. Oh, I bet the date and time is wrong on my machine. That's going to be interesting. Let me sync my clock. And now try that one last time. If this doesn't work, then we'll just move on. Yep, that's going to be a fail. Well, let's imagine that we logged in correctly. Okay, so our next step then is to take a look at the logs. Now here in Cyral, we did integrate correctly with Splunk here. And so let's take a look at the logs that we logged inside Splunk. Now I've chosen to integrate the Cyral application into my Splunk dashboard. And so I have these default dashboards: user activity details, security summary, policy summary, data monitoring activity, and application activity details. But we could definitely craft our own Splunk dashboards as well. Let's dig into data monitoring activity. Now here in data monitoring activity, we can take a look at all of the traffic that we see in our application. Now we have this these bumps of content available to our application, and I'm actually surprised we don't see some more traffic here from our application. So let's refresh the traffic and see if we get some new content here. This could also be the time difference between these containers being a little bit later in time. So we can see that we've got some content from accounting. We've also got some content from our SRE team, and we're able to view the different details associated with that activity. Now we can flip over here. It looks like accounting is doing both selects and inserts, where SRE team is only doing selects. Now that's good. We probably don't want to do a whole lot of data manipulation from the SRE team. We can also take a look at the users and what the users are doing. If we dig into a particular group, we can now take a look at that content associated with that group. So let's dig into the accounting team's activity, and I'm going to flip over to all users for the accounting team. And now we can see just that activity from the accounting team. So here's the selects and inserts that they're doing, the type of queries that they're doing, total records based on repo user and based on actual identity user, the SSO user. We can then dig into the particular logs in this application. So I'm going to click into this particular query. Now I can pull off the client connection ID, and I can pull off the user. And so now we're looking at all the logs in our data store. And the particular thing that we were after when we were trying to answer this question is, who accessed our data. Well, here in our request, we can see, let's look for this one. That was a connection closed request, by the way. Here's our select query. So we've got that select query. We can come here into the response and look at, there were 4 rows to return. That's perfect. And then we can also look at the identity right here together with our request and response details. Now, Audrey from accounting logged in, and we used this service account to get at our actual data. Now, we also added this additional Cyral context inside of our web app to be able to log additional details. So, for example, I happen to grab, here's the application name, the Cyral Spa, and I happen to grab Audrey's full name in here as well, so that we can see more details associated with that application. Now, we could definitely log as many attributes as we need to be able to most concretely identify the context, the identity associated with this query. So what's really cool is we have their name, we have their groups, we have the request details, we have the response details, we have the connection date and time, and in particular, we have the fact that no policy was violated in this case. We have all of those details that we needed associated with this log right in place. That's wonderful.
Okay, Rob, I'm going to interrupt just a second here. We got a good question from Mike that I think is a good place to place this in here.
Definitely.
And he talks about, people are always accessing data, all the time, kind of example there. But, if you really only want to see the abnormal access to the data, to find when someone is using it or sending it somewhere abnormal, like an exfiltration, how would that permeate in here?
Definitely. So we took a look at the data monitoring activity and we saw, hey, there's this spike in activity. That feels a little bit unusual. That might be an indication of an exfiltration attack. Did Audrey's account get compromised that they're doing so much more activity? But we can also set up some policies here in Cyral. So right now I have a policy that says that SRE accounts can only access 5 rows at a time. I'm going to assume that if they do a select star, that they're trying to do malicious activity. Now that's just an assumption on my part, but that's the way I configured my application. So here inside my Cyral dashboard, my Splunk dashboard with Cyral installed, I'm going to come back here to dashboards and I'm going to click on Cyral security summary. Now this will filter to only things that have policy violations. Now we identified previously that in this case, the policy wasn't violated because accounting is allowed to access all the records. But let's take a look at policy violations. Ooh, here's an authentication failure. That's definitely cause for concern. And I can dig into the specific activity associated with that user. So if I have policy violations or if I have particular content associated with that user, then I'll be able to see that here. It looks like Skylar had a lot of trouble logging in today. And now we can see those details associated with that user. Now I'm not getting any response in that other dashboard because he wasn't doing any queries. He was just failing to log in. But now we can kind of dig into what were the policy violations and how might I choose to do this. Now, the cool part here is now that we have visualization into these policy violations or into these abnormal queries, we can start to build alerts inside of our dashboard to be able to highlight this activity. So even in the not user activity, inside the data monitoring activity, we can see these unusual spikes. Now, maybe we're trying to do a data exfiltration attack where we're trying to do a trickle attack. Let me just select one more record. I'm under the threshold. I'm not selecting more than 5 records, but here we're aggregating it. So SRE did 85 record requests in a matter of a few minutes. That sounds like kind of a lot. Let's dig in farther and see if that is a concern. That's how we start to visualize this, is we now have access, we have visibility into the data associated with our activity, and we can hone in on those pieces where that data may look irregular. That was a great question, Mike. Thank you. So we got to see how Cyral was able to proxy not only the details associated with our application, but also the details associated with connections not associated with the application. And we were able to then harvest all of those logs in one place, showing the identity of both application and non-application users in one place. We were able to use SSO with data. That's amazing. Cyral is a great place, the cloud-native security platform for data that offers log identity and query data together, federated temporal authentication, consolidated policies and monitoring across all of our data stores, and real-time attack response. No longer are we just doing post-mortems to try to identify data failures, but we can capture it in real time and block those requests when they match a certain pattern. Cyral is a great place to be able to gain that visibility and also security around our data using SSO. This has been a lot of fun getting to show you Okta. For those of you watching later, hit me up on Twitter at Rob_Rich or at Cyral Inc. and let's continue the conversation. You can grab these slides right now at robrich.org. For those of us who are here live on the event, what are your questions? What are your thoughts?
All right, Rob, thank you. Yeah, we'll get into some questions. This is some great information, presented in a very consumable and fun way, which you always do. And I picked up a few nuggets of information, of course. But I do have questions about, the complications tied to data access. For specifically the shared accounts like service accounts. How do I get rid of those, or do I even want to, I guess?
Good question. And let's come back to this diagram because that's where we see those shared service accounts. Now, we're probably using the shared service account to get access to our data. And then when we get into terminals, then we're using those same shared access accounts to log into our database from non-application usage. Now, the interesting part is that shared service account got us access to the data, but doesn't help us answer the question, who accessed our data? Now, let's add Cyral. We can take that JOT and we can use that JOT to authenticate to our Cyral sidecar, and we no longer need a service account embedded into our application. Similarly, with a terminal, we no longer need that shared service account to log into our data store. We can log in with IDP : and our username, and that will get access to our data. The service account is gone. The only thing that service account gave us was uniform access to our data, but it didn't help us answer the question, who has access to our data? And now without shared service accounts, we can get that shared identity from our service provider, from our identity provider, in this case, Okta.
Okay, great. And I guess is the auditors really, are they interested in who is accessing as opposed to a service account? Is the value of knowing exactly who it is? Does that help with the abnormal activities, like where somebody's working, or as opposed to a service account which may be being used 24/7?
Most definitely. If I notice that there's unusual activity and the only indication that I have is that the service account is doing the activity, then the only course of action I have is either to shut off the service account, which disrupts normal traffic to the application, or let the traffic continue, in which case I know that the attack is proceeding as planned. So I don't have a whole lot of controls here. If instead users authenticate with their identity provider to the data, and I notice a particular account is behaving badly, then I can dig in more carefully. Is that account compromised? Is the user trying to do malicious activity? let me go have a chat with that user. I'll disable their account first, which definitely will cause them some concern. But now I can go have that conversation and understand, are our security policies too tight to be able to block them from accomplishing their task? Or did their account get compromised and it's being used as part of this data exfiltration attack?
All right, great. I've got a question from Harry, and it's kind of similar to or really builds off of the one that we had from Mike, and that is, where you saw the queries or the requests, and you kind of were able to say that they can only do a certain request. So how do I block those dangerous queries? Is that just set up that they can only do so many lines, or can you get any more detail on the blocking those inquiries or data?
Yeah, definitely. And that is such a great question. Policies inside of Cyral are really, really elegant. Here in the Cyral console, I'm going to first stop off at the data map. Now, in this case, I'm just enumerating the content in my Postgres database, but I could also enumerate the content in my Mongo database or in my MySQL database, and I'm just identifying how I identify the data. In this case, I've identified that certain content in my database is sensitive, and here's the repository and schema, table, and field to get there. Once I've identified the types of data I have, I might identify email addresses, social security numbers. In this case, I'm just saying sensitive. Now I can go create a policy that will identify who has access to sensitive data. Now, by default, if any content is not specified here in the policy, it is blocked. So I'm going to say for sensitive data, here are the rules associated with that. Now, for various identities, I can identify the specific types of activity that user can do: reads, updates, deletes. And so in this case, for the SRE group, I've said that they can read at max 5 rows at a time. They can update at max 1 row at a time, and they can delete at max 1 row at a time. So that means if an SRE tries to do a bulk update, it will just fail. It'll get blocked. Now, I could definitely tune these policies to identify other data associated with a request. I can even create custom code using Rego, where I can give it additional verification, and then write a Rego program that will look further into the request to be able to validate additional details. I can get as specific or as granular as I want to, looking not only at the current request, but also looking across time to say, is this a trickle data exfiltration attack? Have they accessed, for example, 40 records in the last 2 minutes? If so, then I'm going to block this request straight away, even if it's less than this quantity of rows. These data policies allow us to do some really, really powerful things to be able to identify the specific context around that query. And what's really elegant is I'm only tracking sensitive data, but I'm tracking sensitive data across all of my repositories, Mongo and SQL Server and Oracle, all in one policy. So I know that SRE can't get at sensitive data in Mongo if they can get at sensitive data in Postgres.
Okay. We have time for one more question, and it's kind of more of a architecture question, because you've mentioned a lot of different SSO providers and logging and databases. I mean, does the Cyral dashboard allow you to, have connectors to all of those, so it's kind of seamless transitions if you're using multiple databases or multiple stores, or to get the right one for your organization?
Most definitely. We dug in a little bit to the databases that I have. I have MariaDB, Mongo, and Postgres. And here in my Postgres, we can see that I can use this SRE group through my SSO provider to be able to access this. So I do need to know that I'm connecting to Postgres as opposed to MariaDB or Mongo, but I'm using the exact same username and password, my identity provider username, and the token that I got for my login. At that point, I can also integrate other things. We talked about integrating various types of databases, but I can also integrate various SSO providers and also various logging providers, or PagerDuty is a really fun one where I can give them access only to data while they're on duty. And so that can be really fun. There's lots of different integrations available in Cyral to be able to connect lots of different data stores, lots of different identity providers, and lots of different logging collectors as well.
All right, great. And they can find that information probably at more detail on Cyral.com, and also the white papers that are available in handouts. So take a look at those. So now it's time to select the $25 Amazon gift card winners. So they are Gianpaolo M, Henrik O, Bianca P, and Mike L. Now you will receive an email at the email address you registered for this webinar with, and they will explain how you retrieve your gift. Now, if you're like me and you have like 7 different email addresses, you don't know which one, you'll just have to, wait and see which one it shows up for. And also don't forget to check your spam folder if you don't receive it. So you will get that information. Now, I want to again thank
Congratulations, winners.
I want to thank Rob Richardson. Rob, why don't you give a plug for the AZ Give Camp, because I think that's a important activity. So I want to give you just one 30 seconds or whatever to give a plug for that again.
Yes, definitely. And thank you to Cyral for making this webinar happen. AZ Give Camp brings volunteer developers together with charities to build free software. Hit us up at azgivecamp.org or meetup.com/azgivecamp and come join us for the next AZ Give Camp. Or if you'd like a Give Camp in your neighborhood, let's get involved and make that happen. It's a lot of fun building free software for charities.
All right, great, Rob. And yes, I want to thank our sponsor, Cyral. And again, go to Cyral.com, learn more about this. I think the access control that you're bringing to this and the identification is so important as we work forward in all of our activities. But I also want to thank you, our audience, for taking an hour out of your day to spend it with us. And so for now, goodbye, and may the fickle finger of fate be kind to you.
Thanks for joining us, everyone.